All right. So the upcoming question is basically a question from the topic of ray optics. It's a question on the relationship between magnification and the distance of the object image, sorry, from the pole of the lens. Now I have analyzed it. So if you find this video long, the purpose is to explain you. Okay. Even I have seen the question for the first time. So we will analyze it and we will then eliminate all the choices. So one of the ways you solve NEET questions or JE questions or any question for that matter, where you have multiple choice question, is the process of elimination. So I've used the process of elimination, which you can also use. And so watch this with patience, because I've tried to analyze multiple options. Though I knew the answer at the first instinct, yet I have deliberately struggled like a student to solve this problem. So let's start the video now and let's start doing the explanation and discussion part. Thank you. All right, good morning. So this question is from the topic of ray optics. It's a question based on thin convex lens. Let's read the question first. So it's a graphical question. Figure shows variation of magnification produced by a thin convex lens and distance of image from pole of lens, right? So which of the following statement is true? The focal length, so you can see on the y-axis you have magnification, and on the x-axis you have the distance of the image from the pole of the lens, and it's coming out to be a straight line with a negative slope. Okay. Now the focal length, first choice, the focal length of the lens is equal to the intercept on the v-axis. Okay. So the question is essentially on this intercept, right? What is this intercept going to represent? Okay. So focal length is equal to the negative of the inverse of the, so we have to establish the relationship of the focal length and with the intercept. Okay. This is the intercept and we have to decide what exactly, how is the focal length linked to this? But let's see. Magnitude of intercept on m-axis is equal to unity. Okay. So he says this is unity. The graph is not possible between object distance and image distance. Okay. Let's look into the choices. But before we do that, a quick revision of the concept of magnification. So, you know, magnification is M, and you can see on your right-hand side, this is the magnification. It is given by height of the image divided by the height of the object, or the distance of the image divided by the distance of the object. Okay. So V is the image distance, U is the object distance. Okay. Now, the sign convention, right? The magnification is positive if image is upright. I don't think so. They have asked for this sign convention, but it's very important to know. And if the image, and if the magnification is negative, it's a real image. Okay. So I think this is a negative slope. So to me, this is a negative slope, means the M, which he has written in the question, you know, the examiner. So M is equal to V by U, right? So this means V is equal to MU, right? So there is a lens with some magnification. And the question is, if there is a lens, and what we are doing with this lens is we are changing the value of V as per the question. So we are increasing the value of V and the value of M is coming down, right? So if it's a thin lens with some magnification, how does it link to focal length is the question, right? So magnification is the intercept. So this is the relationship he has created. We have to decide this particular part, right? So V is equal to MU is, so this is my image distance, this is my object, and my focal length is given by 1 by f is equal to 1 by v minus u. And so therefore 1 by f is equal to 1 by v minus 1 by mv. And if I take the LCM, I get 1 by f is equal to mv. This will become m minus 1. And so therefore this will become mv upon m minus 1 is equal to f. And so I can take the v, which is the, right? So this side is focal length is equal to m upon m minus 1 into v. If I look into this also, right, if a m versus v graph is drawn, okay, with a constant focal length, okay, if the focal length is kept constant, then I have to write it as mf minus m is equal to mv. Sorry, this is f. So mf minus mv is equal to f, and m is equal to f upon 1 minus v. So m is inversely proportional to v. So it cannot be a straight line for sure, right? This graph is not possible between magnitude is, this is absolutely absurd, right? You have, why should the intercept be unity? So focal length is inversely proportional to the negative of slope. So focal length is equal to this. Okay, so can I say that focal length is negatively equal to the slope of this line is m by v, right? M by v is the slope. The focal length of the lens is equal to intercept on the, this represents focal length. I don't think so this represents focal length by any chance. Because here the magnification is equal to 0. So if magnification is equal to 0, then the object is where? Infinity, right? So this is not possible. I think the only choice which is logical is this, because focal length is equal to the length of the intercept on the y-axis. Okay, so y-axis, we can look at that also, which means the m is equal to 0, right? So if m is equal to 0, then focal length is 0. I think this graph is not possible. You cannot change magnification of the lens by changing the image distance. That's straightforward. So I think this was unnecessarily made complicated by whosoever made this question. And to me, the logical answer is this graph is not possible because m is a fixed quantity, right? For a lens, if you have a fixed focal length of the lens, how can it produce more magnification, right? So the point is magnification is being changed depending on the distance you are, right? So now it says that magnification has become 0 at some distance, right? Which is not possible. How do you produce 0 magnification for a lens? That is not possible because it is given by this formula. So if it is 0, then what are we saying? That the object is at infinity or image is at 0. So this makes no sense at all, I think, if we do an analysis. I mean, for a lens, of course, you can have different situations. You keep the object between focal length and the 2f. Beyond 2f, f and o, you do get different magnifications, right? But the magnification is in no way directly, like a y is equal to mx with a negative slope. That doesn't come. So I hope this answers. I think the correct choice is 4. This graph is impossible to make. Thank you very much.